integers.
Introduction. In class 6th, we read about integers and various operations on them. We shall review them here and study the various properties satisfied by various operations on them. Study the given example. Bag of integers, the collection of natural numbers zero and their negatives are known as integers. Number line of integers, a line on which numbers are marked at intervals used to illustrate simple numerical operations. Integers and their representation on a number line. Numbers, natural numbers. The counting numbers are known as natural numbers. So, 1, 2, 3, ... up to infinity are natural numbers. The collection of all natural numbers is denoted by n. Representation of integers on the number line. Every integer has a corresponding point representing it on the number line. Representation of natural numbers, whole numbers, integers on the number line. Natural numbers. The line extends indefinitely only to the right side of 1. Whole numbers. The line extends indefinitely to the right but from 0. There are no numbers to the left of 0. Integers. The line extends indefinitely on both sides. Properties of addition of integers. Closure property of addition. The sum of two integers is always an integer. Commutative law of addition. If a and b are any two integers, then a plus b is equal to b plus a. Associative law of addition. If a, b, c are any three integers, then sum of a and b plus c is equal to a plus sum of b and c. Existence of additive identity. For any integer a, we have a plus 0 is equal to 0 plus a is equal to a. 0 is called the additive identity of integers. Existence of additive inverse. For any integer a, we have sum of a and additive inverse of its is equal to 0. The sum of an integer and its additive inverse is always 0. Note: the opposite of an integer a is minus a. The sum of an integer and its opposite sign is 0. Additive inverse of a is minus a. Additive inverse of minus a is a. Subtraction of integers. For any integers a and b, we define a minus b is equal to a plus additive inverse of b is equal to sum of a and minus b. Difference of a and minus b is equal to difference of a additive inverse of b is equal to sum of a and b. Study the given example. Properties of subtraction of integers. Closure property for subtraction. If a and b are any two integers, then a minus b is always an integer. Study the given example. Subtraction of integers is not commutative. If a and b are any two integers, then a minus b is not equal to b minus a. Study the given example. Subtraction of integers is not associative. If a, b, c are any three integers, then difference of a and b minus c is not equal to a minus difference of b and c. Study the given example. Multiplication of integers. Rules. To find the product of two integers with unlike signs, we find the product of their values regardless of their signs and given a minus sign to the product. To find the product of two integers with the same sign, we find the product of their values regardless of their signs and give a plus sign to the product. Study the given example. Properties of multiplication of integers. Closure property for multiplication. The product of two integers is always an integer. Study the given example. Commutative law for multiplication. If a and b are any two integers, then a multiplied by b is equal to b multiplied by a. Study the given example. Associative law for multiplication. If a, b, c are any three integers, then multiplication of ab by c is equal to multiplication of a by bc. Study the given example. Distributive law of multiplication over addition. For any integer a, b, c, we have multiplication of a by sum of b and c is equal to sum of a multiplied by b and a multiplied by c. Study the given example. Existence of multiplicative identity. For every integer a, we have a multiplied by 1 is equal to 1 multiplied by a is equal to a. 1 is called the multiplicative identity for integers. Study the given example. Existence of multiplicative inverse. Multiplicative inverse of a non-zero integer a is the number 1 by a, as product of a and 1 by a is equal to product of 1 by a and a is equal to 1. Study the given example. Property of 0. For every integer a, we have a multiplied by 0 is equal to 0 multiplied by a is equal to 0. Study the given example. Note, the product for three integers does not depend upon the grouping of integers, and this is called the associative property for multiplication of integers. Any integer when multiplied by 1 gives same integer. Any integer when multiplied by 0 gives 0. Division of integers. We know that division is an inverse process of multiplication. Rules. For dividing one integer by the other, the two having unlike signs, we divide their values regardless of their signs and give a minus sign to the quotient. For dividing one integer by the other having like signs, we divide their values regardless of their signs and give a plus sign to the quotient. Study the given example. Properties of division of integers. If a and b are integers, then a divided by b is not necessarily an integer. Study the given example. If a is an integer and a is not equal to 0, then a divided by a is equal to 1. Study the given example. If a is an integer, then a divided by 1 is equal to a. Study the given example. If a is an integer and a is not equal to 0, then 0 divided by a is equal to 0, but a divided by 0 is not meaningful. Study the given example. Properties of division of integers. If a, b, c are integers, then a divided by b in bracket is whole divided by c is not equal to a divided by b divided by c in bracket unless c equals to 1. Thus, division on integers is not associative. Study the given example. If a, b, c are non-zero integers and a greater than b, then first a divided by c is greater than b divided by c if c is positive. Second, a divided by c is smaller than b divided by c if c is negative. Study the given example.